All right. Everywhere I see an x, I'm going to plug in -2. So 7 minus 8 times a -2. -8, -2 make positive 16. 7 plus 16 should give you 23. Okay. Here, they want me to use this equation, 2x minus 6, plus this equation, 7 minus 8x. Okay. Wherever I see an x in this first equation, I'm putting a 2. And wherever I see an x in the second equation, I'm putting a -4. 2 times 2 minus 6 plus 7 minus 8 times -4. I'm using my order of operations. It tells me I have to do anything in parentheses first in multiplication. So 4 minus 6 plus 7 minus -8, and a -4 will give me a positive 32. 4 minus 6 is -2. 7 plus 32 is 39. And -2 plus 39 is 37. And I continue to do them in pieces like this. That's how I did it. Do you have to put the parentheses? No. That's how I handled it. All right, next. Let's graph. What form is this in? If you said slope-intercept form, you are correct. Y equals mx plus b. M stands for, if you said slope, that's correct. And slope tells us how to move. B stands for, if you said y-intercept, you were correct. And the y-intercept tells us where to start. Let's go. So my M in this one is -2/1. My B is 4. So that's going to be 0, 4. It means I start at 0 and go up 4. 1, 2, 3, 4. I move down 2 and to the right 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. I connect the dots. And I just graph that function. Done. This one is missing something. I'm missing the b. So first thing I should notice is if that's just y equals something x, that is a direct variation. And the b is always 0, 0. Right? So that's where I'm going to start at. My M is 3, so 3/1. So I'm going to start at 0, 0, and I'm going to move up 3, 1, 2, 3/1. I'm out of room, so I just got to make sure I keep this positive. So I can go down 3, 1, 2, 3, but I got to go to the left, and that keeps it positive. And I should also have a point right there at the origin. Connect those, and I'm done with that. Okay, don't forget to put that point there at the origin. Next, Araceli's profits at a craft fair is represented by the function P equals 5B minus 15, where P is the profit and B is the number of bracelets she sells. Nia's profit is shown in the table. This looks very similar to this y equals mx plus b, so I'm going to write that above it. Y equals mx plus b, plus or minus b. All right? Nia's profits are in this table. And what they're asking me to do is compare the y-intercept and the rates of change. So it's almost better if I put what's in the table into an equation. So let's create an equation for that. I know I can find out my equation by remembering this direct variation. Okay? And that is also the same. To find out m, I do y divided by x. So let's go. 5. And this is my y, this is my x. So 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3, 20 divided by 4. So my m, since it's constant, is going to be 5. So now I can use this equation to write it out. Y equals 5x. So this is Nia. And Araceli, I can rewrite her equation as y equals 5x minus 15. Now let's compare the two. They have the same rate of change. RC of 5. Araceli's y-intercept is negative 15, and Nia's is 0. That's it. So you have this explanation, show your work, and you're done. Remember, if you have any questions, let us know. How much will each girl make if she sells 25 bracelets? 25 bracelets. If I look up here, B was here, X is here, so I know this has to represent X. So let's plug this into the equation. 5 times 25 minus 15. 5 times 25 is 125 minus 15 will give me 110. Nia, 5 times 25 will give me 125. There you go. Number 14. A water park charges a rental fee of $1.50 per hour to rent inflatable rafts. Right here, this is a rate of change. So this is my M. The total cost to rent a raft for 6 hours is 15. So hours is going to be my X, 6 hours. And is, that's the equal sign, and Y usually goes on the underside of that equal sign. So my Y is 15. I'm going to circle that. All right. Assume the relationship is linear. Write an equation that represents the situation. Find and interpret the rate of change and the initial value. So I have an M, an X, and a Y. I can always use my slope-intercept form because I have a slope. I have X and Y, and I can find out the rest. So that's a point. And I also could use point slope form, but let's use slope intercept form to find out our B. Let's do it both ways. Point slope. Point slope is y minus y1 equals m times x minus x1. Y minus 15 equals 1.5 times x minus 6. This is the FOIL, so y minus 15 equals 1.5x minus 6 times 1.5 should give you 9. I add 15 to each side. Y equals 1.5x plus 6. Okay? So you can do it using point slope form. That's one way. Or you could use it doing slope intercept form and solve for B. So remember, that's y equals mx plus b. So my y was 15, my m was 150, my x was 6, and we don't know what b is. We know this is 9, so 15 equals 9 plus b, minus 9 for both sides. You should get 6 equals b. So you can do it, that's 2 different ways you can do it. Okay? And then they want us, so we wrote the equation, we got 2 equations that represent the situation. This is the equation that represents the situation. So you would have to take this and then rewrite this equation. So I would recommend using point slope form so that you can make sure that you have the equation written correctly. Find and interpret the rate of change in the initial value. So I have to interpret this now. It costs $6 to rent a raft, and then $1.50 per hour. This is my final answer right here. That's what I want you to have. All right, let's keep moving. All right, we're going old school. That's because this is something we did earlier in the section. Determine whether each table represents a linear or nonlinear functions. Explain. We have 2 ways to do this. Change in y over change in x. And that's when we go, is it increasing or decreasing? Is it increasing or decreasing? Is it increasing or decreasing? And we have to do the same thing. Increasing or decreasing, increasing or decreasing, increasing or decreasing. Please pay attention whether you have x or y. This is your x. This is your y. Pay attention to that. Okay, that's one way. And the other way is y divided by x. So this will give us m, and this will give us m. But it has to be constant throughout, okay? So way number 1, plus 2. This is changing by plus 1. This one's changing by plus 2. I can stop right there for that particular way of finding it, because right here, it's not constant. I'm going to just show you here, plus 2, plus 3, plus 4. It's not constant. It's not constant. Then I can also try it this way. Okay, this is undefined because we can't divide by 0. Then we got 3 over 2. Then we got 6 over 3, which is 2. And then we got 10 over 5, which is 2. So there's no constant here. So this is non-linear. Okay, I showed you 2 ways to do it. If you got questions, let me know. But these are the 2 ways to do it. We're doing the same thing over here. Minus 2, minus 4, minus 2. Well, that's not constant. I don't even have to do it up here, but I'm going to do it. Plus 2, plus 4, plus 2. Okay? It's not a constant rate of change. I can also try the direct variation way. 12 over 0, we know that's undefined. 10 over 2 is 5. 6 over 6 is 1. 4 over 8 is half. That's not constant either. So this is also non-linear. Okay. 17, the graph below displays the distance Dillian rode his bike. Describe the change in the distance. So right here we see that as time is going on, the distance is increasing from this beginning point. Then the distance stays the same, so we're not moving, but time is still passing. And then as time goes on, distance starts to increase. So let's give a story for that. So Dylan rode his bike from home to the park. Along the way, he saw a friend and stopped to talk. Yes. He continued on to the park after talking to friend. Okay? That's what this graph is telling me. That's the story I came up with. Nothing to do with hill. He didn't go up any hills or anything. Remember, this is distance. This is time. So as time is passing, he's getting further and further away. Okay? Right here, time is passing. It's flat because he's not going anywhere. He's standing still. Okay? Time is always happening. He's standing still. And he doesn't start moving again until right here. So he's getting further away. Okay? He's not going up any hills, down any hills, anything like that. Right? So here's a good explanation. You can come up with your own thing. He can be going from home to the store. He could be going from home to the store and then to school, wherever you want him to go. But just make sure you represent that he left from somewhere and he was going on his bike. He stopped. This means you stopped somewhere. Give us a reason why. And then he kept going. All right? So, number 18. Says a lion cub is resting in the grass. He sees another lion cub nearby and races after it, picking up speed as it runs. Sketch and label a qualitative graph to represent the situation. I'm not going to deviate from what I already know. He is talking about time and distance again, okay? It's talking about how far he was resting, so time. And then we could put this as distance, or we could put this as speed, because they said speed, so we're going to go with speed, all right? So at first, his speed was non-existent. He wasn't going anywhere, so it's nice and flat. And then he sees another lion cub nearby and races after it. He's running, but he picks up speed. Oh, we're curving up, okay? So this should be a nice curve because he started picking up speed. So instead of going nice and slow, here it was taking him longer. But as time went on, his speed increased. It picked up speed as he ran. So you should have something with a curve. Speed and time. That's what you're going to do. Whatever they give you, if they give you speed, use speed. If they give you distance, use distance. Keep your bottom as time for the most part, especially if it's talking about resting. 19. Write the steps to solve a system of equations by graphing. So, system of equations by graphing steps. Change. So that just means the equation should be in slope-intercept form, so it's easiest to graph. Identify. That's recognize what M is and B is. Find M and B. Then you're going to graph. Then you're going to repeat this. So first equation. Then you're going to repeat steps 1 through 3 for second equation. And then I'm going to find a solution. Okay? Or our point. We call that our point. So, solution can either be a point, solution can either be a point, which is one solution, no solution, which are parallel lines, or infinite solutions. Same line. Okay, and you can look in your notes about, they have different m values. I'll just write that real quick. Different m's, one solution. Same m, diff b, no solution. And same m and b, infinite. All right. 20 steps for solving substitution. You guys should know this. Isolate, substitute, solve, second variable, point or solution, and check. All right, almost finished, people. Solve each system of equation by the graphing method. So you're just actually going to graph. Right here, y equals x. So if y is 1, x is 1. Y is 2, x is 2. Y is 3, x is 3. Okay, so this is going to be a consistent line. Let's go. So it should go straight through the origin, all the way across. All right, that's that line. Let's graph. So I graphed that one. Bam. This one is already in slope-intercept form for us. And this is also direct variation. So I know my B is 0, 0. So that's how I knew it went through the origin. And my M was 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay? Remember, each of these lines count as 2, so don't let that confuse you. Anyways, my B for the second problem is -4, so 0, comma, -4. And my M is 2, so that's going to be 2 over 1. So I'm starting at -4, I go 0, and I go down to -4. And I'm moving up 2 over 1. So remember, each line is 2. So I got to move halfway to go 1. So up 2 over 1, 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 up 2 over 1. All right? And here's where it meets. So my solution here is 4, comma, 4. Done. Let's do this over here. Both of these are in slope-intercept form. So my slope for this one is negative 1 over 2. My b is 5, so that's going to be 0, 5. Let's graph. I'm starting at 0, 5. Okay, these right here are going by 1, so just make sure you pay attention to how your graph is made and what each line is worth. So these are going by 1. So I have to go down 1 over 2. Down 1 over 2. Down 1 over 2. All right. All right. And then this next one, m is 3. And my b is negative 2. So I'm starting at 0, negative 2. 0, negative 2. And I'm moving up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1, somewhere out here. All right, I have a solution. It is 2, 4. Done. Last one. Solve each system of equation by the substitution method. First thing I want to do is isolate. My variable is isolated, so I'm good. And this variable is isolated, so I'm good. Now I want to substitute. So I'm going to substitute this one into here. So wherever I see a y here, wherever I see a y here, I'm going to plug in this. Sorry. All right, so let's go. 2x equals x plus 15. Okay, sorry I scribbled out this y, I just don't scribble it out. So let's solve. So I have 2x here, and on this side I have x plus 15. So I got to remember my steps for solving equations. Distribute. Combine. Rewind. Solve. Check. Okay, can I distribute? No. Can I combine over here? No. Can I combine over here? No. Can I rewind? Yes. I want to get whatever variable I have all by itself. Okay, so I'm solving for what? X. So I'm going to put the x's together. Remember, I don't want to move this over here because then there'll be nothing over here. Let's move the x's. If it's x over here already by itself, let's move that other x over there. So minus x, 2x minus x will give me x equals 15. You just solved for x. So now that I have x, I'm going to plug this one in, and I'm going to put here. So I know my first point is 15 for x. So now I'm going to plug in this 15 wherever I see an x in this problem. So I'm going to circle it. Let's circle this and draw a line. So now y equals 2 times 15. 2 times 15 is 30. So y is 30. That is my solution. Let's check it. We're going to plug both of these into this first equation. 30 equals 15 plus 15. Is 15 plus 15 30? Yes, it is. Check. All right, let's go over here. This one is not in slope-intercept form, so I need to isolate the variable, okay? I can isolate the x or the y. It's up to you. I'm going to isolate the x because it's already single. I don't need to do any division. So I'm just going to move this 4y to the other side. Minus 4y. Minus 4y. X equals 8 minus 4y. Okay? So I've isolated my terms. Now let's substitute. Wherever I see an x here, I'm going to plug all of this in there. All right? Let's rewrite it. Y equals 1/4 times 8 minus 4y. Time to solve my equation. Can I distribute? Yes, I can. Right? So here, I have a 4 on the bottom of here. I have a whole 8. So I can actually reduce this. And I know it's actually going to end up being 2. Okay, and I'll show you that work. It'll be 8 over 4 minus 4 over 4. Y, 8 divided by 4 is 2. 4 over 4 is 1, so that'll be y equals y. Okay? Next, I have to combine. I can't combine over here, and I can't combine over here. Rewind. I got a y over here already, so I'm going to just bring this over here. Plus y. Remember, pay attention, guys. Don't make these mistakes. Y plus y is 2y equals 2. I know some of you would have saw that. You would have tried to subtract y from both sides. No, we're adding y. We're adding y. All right? Now I have to divide by 2 on both sides. Y equals 1. All right, so I got my first part. I know that y is 1, so I can put that in there. So now, wherever I see a y in this equation here, I'm going to plug in 1. So wherever I see a y, I'm going to plug in a 1. So let's rewrite it. X plus 4 times 1 equals 8. And remember, I'm solving for x now. So x plus 4 equals 8 minus 4 on both sides. X equals 4. All right. Solving equations. All right. Let's check. I'm going to use this first equation. Y is 1 equals 1/4 times 4. And we know that 4 times a 4th is 1. Check. This is your study guide completely done. I hope you got everything you needed.